Okay, what we have here is a little test that Graham and OUR asked me to look at. Actually, he asked me about the schematic, but I got curious about running this test. Got a transformer with the primary, which was supposed to be 120 volts, and the secondary center tapped 12 volt. And the idea is, what happens if you have one of the secondaries shorted, apply a pulse to the primary, remove the pulse to the primary at the same time you remove the short from the secondary. And what you're seeing on the scope is what we get if that's going on. And in order to try to analyze it a little more, I added a bridge rectifier down in all this mess somewhere across the leads of the secondary, and then took the output of that going to this cap. And this meter is showing the voltage on that cap. This is with the short being applied to 1/2 of the secondary from the center tap to one side. It did not seem to want to work well trying to short out the whole secondary, but shorting out half of the secondary gives an interesting result. You see the high spike? Now watch what happens when I remove the shorting transistor that's shorting it out. Reach down here and remove that. Now look at it. That big high spike is all gone. And if we look at the meter, we'll see it slowly starts to drop. And of course, it's just slowly bleeding, the cap's slowly bleeding off. And it likes to get down to only like about 12 volts. The interesting thing is, I'm only putting 12 volts into the off this battery into the primary, the transformer anyway. But that's a little phenomenon that we discovered back quite a while back when we were messing around with the Tesla switch circuit, that if you pulse unidirectional pulses, very short pulses into the primary, the secondary just kind of goes to whatever it needs to match up with the load. Another little weird thing here. But anyway, you can see the still dropping. Now I'll reach down here and connect it back up. See the pulse went back, and you'll see the meter start to climb back up slowly as it starts charging that cap with those pulses. So there's something to this circuit. I'm not exactly sure if this is something we can use or not, but I thought it was interesting that shorting the coil out and applying the pulse, or removing the short and the pulse at the same time, gives you definitely a high pulse output. Of course, that's kind of what they do with lawnmower magnetos. The points are closed, the magnet approaches the coil. As the magnetic field gets maximum, the points open, which allows then the magnetic field to collapse. So it's kind of like that idea, but a little bit different. But see, the battery is going, the cap is going right on up, 22.4 now. And that's not a real big cap. So I think it's 140 microfarad or 180 microfarad and 140 volts or something like that. I don't have it around, but anyway, they're very short, narrow pulses. We're actually pulsing at about 5 millisecond pulse. Zero in here. Yeah, I don't know if it's going to come into focus so we can read what the time is. 2 milliseconds per division, and so you can see, kind of look there and get an idea of what that is. Anyway, thought I would video this. I'll see if I can get it posted, and maybe post a little circuit too so you can see what I'm looking at. And we'll catch everybody later.